We are preparing for getting in contact with Robin Phillips. I have a discussion planned with him. He had a presentation yesterday on his Martian robots. And now we want to have a discussion a little bit on his background and how he came to be an astrophysics man and wanting to go to the moon and to the Mars. We are waiting to get a contact and will soon see his face on the screen. We see the opening slide. Hello, this is Robin Phillips again. And Hi. He's still on the Mars. He didn't move since yesterday. How is the weather? How is the weather on the Mars?
I'm still searching for Matt Damon. I haven't found him yet, I'm afraid.
Yes, how is the weather?
Cold, as usual.
Minus 100 degrees or something?
Well, if it was night here, it could be down to minus 130.
Minus 130 at night?
Yeah.
And
yes,
during the daytime?
Right. During the day, it just scrapes above freezing, the freezing point.
Just above freezing. But yes. you don't look like you are wearing like a fur coat or something and a cap?
No, I have to admit I'm wearing the JPL Mars 2020
Okay,
logo t-shirt.
You're actually reporting from Switzerland, from Sachsen, on the beautiful
Correct.
lake of Sarnen, and I had opted to have a little bit more personal talk to you. Are you ready for that?
I think so.
How old are you?
That's a good question. I'm old enough, so I have to calculate it each time from my birth year. I think it's 47 right now.
47, okay.
Yes.
How long are you already living in Switzerland?
So I've been in Switzerland for 13 years.
13? 1-3?
Yes, 1-3. 1-3,
okay.
Correct.
With your family, everybody?
Everybody, all 6 of us are here.
6 of you? That means you have 3 women and 3 children?
4 children,
okay.
Of which 3 are female.
Sorry for the bad joke.
So it's 4 females.
And yes, and the kids go to Swiss schools and speak Swiss German?
That's okay. So they all go to Swiss schools. They've been going through the village school here.
Yeah. Okay.
And the younger 2 who were born here speak Swiss German. The others just speak normal.
You are a UK person, born and raised in the United Kingdom?
Only born. I was raised in a mixture of the UK and Germany. That's why I can also.
Where exactly?
Freiburg im Breisgau.
You moved already in early years in Freiburg im Breisgau to Germany?
Right. Between 4 and 9 years old I was in Germany.
Dann können wir jetzt Deutsch reden.
Das können wir gerne.
Okay, but we keep the English language for the rest of the audience. We have some Japanese people, from Chinese people, from Australian people, from US people, from many places over Europe which want to follow our discussion. Now, right. I was very curious to see that you started in mathematics, if I'm correct?
Yes, that's right. I started off with a bachelor's in mathematics.
And then you extended to astrophysics. That means between mathematics is pure numbers, and astrophysics is about planets and about stars and about the moon, the sun, and Mars. How come this change?
Well, I'd always been interested in astronomy. I think when I was really small, I wanted to be an astronaut, of course.
An astronaut?
An astronaut. But then, of course, I have the wrong nationality for that. You really need to be American or Russian.
Okay.
Maybe you have a tiny chance if you're a continental European.
The British didn't have powerful rockets to go there.
That's right.
But you have worked.
I always really had more interest in the unmanned exploration of the solar system. I remember as a teenager following the Voyager missions to Jupiter, Saturn, Uranus, and Neptune, and things like that.
And you remember, Mel, when Mr. Armstrong had his famous first step on the moon, right?
I was not alive then. That was 3 years before I was born.
Oh, okay. That was even before.
I was actually born as the last mission, as Apollo 17 was on its way.
Okay, sorry, that's my generation who lived through that.
But to come back to your original question, I mean, after I'd done my bachelor's in mathematics, then I was looking for something that would sort of let me follow this interest, and that's how I ended up with astrophysics.
Yeah.
And that then took me to the US.
To Hawaii.
Where I was working at the telescopes on Mauna Kea there.
Is Hawaii prone to have big telescopes? They have clean air?
It has extremely clean air because it's away from all industry. you normally want extremely dry air for astronomy. And most people, if they think of Hawaii, think of the tropics, which is correct lower down.
Yeah.
But it has very high mountains, over 4,000 meters high, that stick out above the moist lower air. There's an inversion layer that's almost permanently there. And then the top of the mountain is absolutely dry. And it's one of the best sites in the world for astronomy.
Could we do the same thing on Jungfraujoch? There is a telescope over there.
That's correct, but we don't have the inversion layer here continuously, so it's still moist on top of Jungfraujoch.
Okay.
The European equivalent is I forget the name now. The islands out in the Atlantic that belong to Spain.
Okay.
Not going to come to me now, but anyway, there's a volcano.
It needs to be clean air and dry air to see
correct.
To the moon, to the stars, to the planets.
Correct. Yes, that's right.
And then astrophysics. I can imagine you had always a telescope at home, a little one.
No, I've never been into the optical telescope.
And none of your children has a telescope?
Not really, no.
But Christmas is coming soon.
When we were living in Hawaii, I took the older ones up the mountain, and there's a visitor center there where they do have sort of medium-sized telescopes that you can look through. Yeah. I enjoy doing it every now and again, but it's not a hobby of mine that I.
Yeah. Now, trying to trace your path from the UK, born, Freiburg in Breisgau, raised, studied in the UK, and then went to Hawaii for this telescope business. And then, at what point did you land in Saxland at Maxon?
Well, there is a thread that runs through this, because then from Hawaii, I went to Canada to work with a group that built telescope instrumentation, so the instruments that go on telescopes. Yeah. And we were building units that go on mountaintops where people are thinking of putting a telescope. So we would measure the atmospheric water vapor. So I went to Chile quite a lot, to the very high mountains in the Atacama Desert, and we would install these remote-controlled instruments on top of the mountain. Yeah. And because they were remote-controlled, they had motors in them, because they had to do all the movement automatically. And we then had an offer to take some of these instruments to the Antarctic and install them on some of the high locations in Antarctica, although unfortunately I never went personally. And for that, we had to modify the motors to make them work at the very low temperatures. Yeah. And so I ended up taking the motors apart and sort of changing the grease inside them and things like that. And the motors we were using were Maxon motors. And so that was where the connection came. And then
that
when
means Maxon was already there were usually small size motors, right?
Correct.
Small size motors that were used in such research operations.
Yes, that's a typical sort of application that we would have on the science side. People want a handful of motors. They can either use our catalog standards or they want modifications, as I was explaining yesterday. And that's what we do, is modifying things for custom applications. Yeah.
Why is Maxon such a special manufacturer of? Is it a clockwork idea of the Swiss watchmakers, or what is it?
Absolutely. I think it's not coincidence that Maxon is in Switzerland. It's because of the Swiss emphasis on precision parts, which is driven by the watch industry, and there's no doubt about it. A lot of our suppliers for the key parts that we have are suppliers for the watch industry, and that's where our suppliers learned their skills.
Yeah, watchmakers, Maxon, Saxland. And when did you actually move to Maxon, to work with Maxon?
That was why I came to Switzerland, so 2008.
2008, that's the 12 years ago you mentioned at the beginning.
Yes.
And did Maxon at the time already have a space lab, or was that initiated by you?
The space lab is just 1 year old. We've, as the organization, as I was explaining in my talk yesterday, part of the problem of doing this space work within a company that's really trying to make money out of industrial products is the conflict between the amount of engineering resources that goes into building 5 units or 10 units that have to go to Mars that literally require man years of engineering resources. Yeah. And that's a conflict with a company that's actually trying to do production of 100 units, 1,000 units, something like that. So that was why we split them apart. But Maxon has always done the space motors since 1997 with the Sojourner rovers. Okay. And I think it's not quite coincidence. It's because the niche Maxon's been going after has always been these sort of specialist modifications to standard products. We undoubtedly had a CEO at the time who was personally interested in these things, and he said, doesn't matter whether we make money on these or not, let's go and support the space industry.
Okay.
And it's had a payback over the following 30 years or so.
But technology-wise, there are synergies between the precision, small size, high efficient, high rotation per minute motors Maxon was making and selling on planet Earth, and applications you used in outer space. There are synergies.
There's big synergies, and it's surprising to a lot of people to know that the motors that we use as our starting points when we're doing a space motor are our medical motors. So about 50% of Maxon's turnover is medical products, and that's because medical products have to be autoclavable usually. So, a typical application might be a bone drill. If you break your bone skiing and you need them pinned, you've got to drill into them.
Yes, okay.
And the drill that's used for that has to be autoclavable, i.e. sterilizable.
Autoclavable means high temperature sterilization.
That's right. So you've got to sterilize them because, of course, the splatter that you get as you're drilling into somebody, you don't want that on the next person. These drills are expensive, so you have to sterilize them. And the things that you have to do to design a motor that lets itself be sterilized and not break turns out to be the same sort of things that you have to do so that they don't outgas in space, so that they have the suitable materials, and so that they're generally robust enough. And it actually goes in both ways. What we then do in the space products.
You learn things which you can take back on Earth.
But goes back to the medical applications.
Yeah. And now, these days, the Space Lab and all these outer space products is a profitable unit of Maxon, or are you still sort of a fantasy niche?
The aerospace business unit is a profitable section of Maxon.
Okay.
The Space Lab belongs to the R&D part of the company. So it's our goal is to develop technology and support these missions that have a high profile and not make profits. But the other half of that is we don't deliberately make a loss. Yeah. So we're trying to cover our costs and develop technology at the same time.
Okay. But the continuation of your work is clear. You will continue on this work and Maxon will hold on, even if there are no short-term big profits on that.
There's a lot of missions coming up at the moment. These follow-on Mars missions. So there's plenty of work for us to do there. It's been very good for Maxon because of this technology development. You see, if you're a company operating in Switzerland, as all the other companies in Switzerland know, you can't usually sell on price. You're not trying to be the cheapest person in the world. You're trying to be the technologically the best person or deliver the highest quality. Yeah. And to do that, we have to invest in R&D. And this is one method that Maxon uses to invest in R&D. Okay.
Now, I'm curious. How did Saxon's CEO, Eugen Elmiger, is he the CEO?
He's the current CEO, yes.
Yes. How did he meet NASA? How did he meet the US Space Organization?
So you have to remember the initial meeting was back in 1997, so that was before he was CEO. That was the previous one. And it's through the normal sales organization that we have. So Maxon has a worldwide sales network, and the
already then,
already then, yes, correct.
Yeah, okay.
And the people in the US responded to the requests from the Jet Propulsion Laboratory. So that's the part of NASA that does the interplanetary spacecraft. And they responded in such a way that we quickly came to an agreement on how we were going to do that. And then the JPL people come to Saxon. And they do a lot of reviews on us. So I didn't have enough time yesterday to go into the detail of that, but how you work with your customer and how closely you have to work with them. Because they're flying a mission that thousands of people are working on. I mean, the Mars 2020 mission is a $2 billion mission. Mm-hmm. And if we have a critical part in that, they don't just trust us to say, hey, here's the motor, it's going to work. Yeah. They come and they inspect everything that we're doing.
They check how you check. Yeah. Okay.
Correct.
I understand. Right. Yeah. But in this sense, the US space program, the major space program I think we have, is a good client from you.
Absolutely.
It's a continuous relationship.
I hope we're a good supplier, and they're certainly a good client for us. We work together pretty well.
For the last part, I want to switch a little bit the topic. I've seen you've also discussed hypersonic flights.
I don't know specifically what you're referring to there, but I mean, it makes sense.
There's this dream that we go from Saxon to Kloten, take a plane, and 2 hours later we are in New York.
Right. So, I mean, that's one of the things that SpaceX has been showing as a possible long-term use for their reusable technology here. And as I mentioned yesterday, we've been working with them for nearly 10 years now.
Yeah.
So, I mean, indirectly, we're certainly involved in some of these programs.
And what's the kind of propulsion system you need to go in 2 hours from Stockholm to downtown New York?
Well, you either need existing rocket technology, or you go for something like scramjets that can absorb supersonic air. That's one of the problems you have with existing jet engines, is you have to slow the airflow down so it's subsonic when it's inside the engine. That's these sort of big mechanisms you see on the front of Concorde or planes like that.
Okay.
And scramjets can accept supersonic.
Okay, good.
Airflow.
Good to hear. Now to my last part. You work on Mars. How long does it take to have a rocket travel to Mars?
So there's things called the Hoffman transfer orbits, which occur roughly every 2 years, and they're what you might consider low energy orbits. So you don't need a huge rocket to get onto these transfer orbits. And then they take somewhere between 6 and 9 months, depending on the alignment of Mars and Earth. It's not the same every time they come past one another, because Mars and Earth both have elliptical orbits.
You sort of have to wait.
They're tilted.
You have to wait to get a good window to hop over there in 7 months, not in 9 months.
7 to 9 months. That's correct.
Yeah.
If you're going to take a very heavy spacecraft, then you sometimes have to do these wind-up trajectories where you fly past Venus first, and you use what's called a gravity assist, where you steal a tiny piece of the energy that Venus has whilst it's going around the sun to speed your spacecraft up, and then you fly back past the Earth and you steal a tiny piece of the Earth's energy, and that can get you to Mars with a much heavier spacecraft than you would do otherwise. But that takes longer. It takes a year or two to do that. Okay,
now my last question is an obvious question. Are you going?
Several people have asked me that. My standard response is only if I can take my family with me, to which my wife usually reacts in horror and says, no way, I'm going with you there.
You could have taken at least your children, because when it takes longer, they have time to grow. And okay, but you said you're 47, you have some time to decide. I read that within the next 10 years, commercial flights to Mars would be possible?
Commercial flights, I very much doubt. I think we might see the first people in 10 to 20 years.
First 10 to 20 years?
Even that's pushing it.
Okay, then think about your children.
Right.
Maybe
it's a chance for them.
Not
it's
about me, certainly. Maybe about you and your wife, but maybe your children.
Right.
Robin, it was a pleasure to see you. It was a pleasure to talk to you. I think my intention was to give a little bit of a realm of fantasy to what an engineer does, and to stimulate other engineers who are sort of working on down-to-earth, everyday machining and electrical wiring, and have maybe in their day-to-day business lost a little bit this fantasy realm that engineering has a capacity for. And I think what you do, what Maxon does, what you do in your space lab, has certainly, it's not science fiction, it's reality, but it has the potential of stimulating people to go beyond what they already learned in school. You're a good example.
Right, thank you. Yes, I mean, we absolutely agree with that. That's why we're doing it. It's a fascinating job to be able to do. We do quite a lot of what you might term public outreach by going to schools and to universities and try to explain to the next generation of people that when you're selecting which subjects you have to choose when you're going to university, or when you're 16, what are you going to do in the upper levels at school, take the harder physics and engineering related subjects, because that's where the really interesting work is later on.
Yeah.
And it's not always visible to you when you're learning mathematics in school. That's not normally very exciting, but it gets you into these jobs later on.
Yeah. Thank you. It was a pleasure to talk to you and to see you a little bit more as a human being with your own dreams and hopes and occupations. Greetings to your family.
Okay,
Bye-bye.
thank you.
Thank you.
Bye.